и очередной доклад.
Hi, stand off. And our next speaker is Head of Reverse Engineering Department, Mr. Dmitry Sklyarov. Cybercriminal Minds Ransomware Edition. Dmitry, the floor is yours. Hi all. My name is Dmitry Sklyarov. Actually, my presentation is called Programmer Minds. Couple of words about myself. Indeed, I'm involved in reverse engineering for more than 20 years. For 12 years, I worked in Alcomsoft, specialized in password recovery. I've been lecturing in InfoSec department in BMSTU. I'm head of reverse engineering at Positive Technologies. I'm a speaker at multiple presentations, and you can Google it and find it. I'm not too interested in concealing myself. One acquaintance of mine living outside Russia back in August 2019 became a victim of ransomware. All his files were encrypted. It had a .masoc extension, and since this person is not an IT guy, he had no backups and he didn't store the virus sample that he encountered. I'm not a specialist in analyzing ransomware. I've never worked in an antivirus company, but I do have certain experience in that. One of my acquaintances back in 2010 addressed me for help, and I managed to help him even without seeing the virus sample because the coding was really simple. It's not really encryption, it was just coding. I looked at how it works, and I wrote a special program and restored the encrypted file. And the 2019 was written in HTML application. It's a combination of HTML and JavaScript. It was very interestingly realized in terms of social engineering. But before the virus was there, the decoding key was there in the computer. You could have taken this key, stored on a disk until the infection process was completed. It would have been easier. In 2012, it was when strong encryption was used, but key was stored on disk until the infection process completed. And 2014, it was RSA private key, so you couldn't decrypt it in case of you didn't have this private key. In a couple of months after the incident, they renewed utility to decode of one of the vendor could already work with this kind of files, and you could restore the data. But the trend is that year on year, the encryption means are getting better and better, and you are standing less and less chance of restoring the data unless you are the author of the malware, of the ransomware. So when somebody addresses me and says that somebody suffered from ransomware, what can you recommend? What I explain is that you have two options. Option number one is to pay the ransom. In case of my acquaintance, they wanted to have $980 equivalent in bitcoins, and allegedly they would give 50% discount if paid within 72 hours, just like in offers proposed of many companies. And most probably you get data back in 15 minutes right after you pay. Your support is perfect. They answer all your questions and they do everything perfectly fine. So people fight for their reputation. Like if you pay, your data gets restored, because if the data is not restored after the ransom is paid, nobody pays any longer. Second option is not to pay. You might want to try and recover the data all by yourself, but most probably you don't have enough knowledge and experience to do that. Most probably you'll have to spend a lot of resources, a whole bunch of highly qualified specialists, and unfortunately, in case of solid cryptography, chances are high that you won't restore the data. The acquaintance of mine has this principle: never negotiate with terrorists. So He just didn't even look at the option of paying those money. He has the money, but he just didn't want to participate. So I agreed to help him out. So first thing we can do is search in the internet what goes on and what has been done to restore data after the ransomware attack. If you enter the search, if you search right, and after you filter out all the sites that has Masoch in the name of it, you get a page in blippingcomputer.com. In the left-hand corner, you can see that first message in this tree of messages was in February 2019, and when I did the screenshot, and it was last year, it was more than 10,000 messages. So it's not new, and it's very important topic. It's a family of ransomware that's called stop.dejavu that adds a lot of kind of extension, including Masoch. That's how I realized that, oh, Masoch, that's right. This is what I need. So if you look at the general message, not all the 10,000 messages that are there in the chat, but some of them, looks like when malware tries connecting, it tries to connect to the CnC. If a success, he gets ID and key. Otherwise, the so-called offline ID and key is used, that is hard-coded inside the malware. And each file contains the ID it's encrypted with, and it's encrypted on a key that is calculated from either the server or the internal archive of the ransomware. People on this forum have carried out a lot of activity and accumulated a lot of virus samples. They got the offline IDs and keys and even created a utility to work with online and offline keys. I tried it. Turned out that out of 284 files that were there in the disk, only one was encrypted using this offline ID and key. And turns out that this utility, well, it might be brilliant, but it's totally useless in my particular case. Great! It means that we should do it ourselves, because you can't use the ready-made tool. So I started to analyze what's there in the disk. A quick look at encrypted files shows us that you have this lengthy unique text, no, not unique, actually, text identifying GUIDA format that prevents reinfecting the files, and also 40-character alphanumeric infection ID just before the tail. And it was easy to notice that, if you know how files work, like PDF documents usually start with a sequence percentage, PDF minus, and then the version of a PDF file. So in my case, all PDF files had first 5 bytes that match its file type, then a lot of encrypted data, and then exemplified by text files. Bytes after offset 153, they are not encrypted. So basically, they encrypt 153 kilobytes with offset of 5. I looked through all the data. It turns out that 2% of the files are not encrypted, and the rest is encrypted, and you need to do something about the encrypted bit. I also had an interesting finding. If you ever were interested in Microsoft Office internals, you probably know that in the previous docs and XLS, not the new ones that are based on zip archives, but the old ones that Microsoft developed all by itself long ago, the first 24 bytes are always identical. You have an 8-byte sequence that's there in Microsoft standards, then 16 null bytes. And in all the encrypted files with doc or XLS extension, first 4 bytes are identical. Looks like they're using stream cipher with synchronous ID. If you're interested in encryption, looks like plaintext attack to me. That's what I tried to apply. The way it works, you find a couple of encrypted and non-encrypted files. I mean, same file, encrypted and non-encrypted. when then you have a XOR overlay and you get a cipher key stream. Then I take other encrypted files in the same way, and looks like you can decipher files pretty well. I checked it on several Excel documents and Word documents, and it works pretty well. Well, there are certain difficulties and limitations to this approach. Limitation number one is that the deciphered file that you pair with has to be at least 153 bytes. Otherwise, it would be possible to decrypt only files that's shorter than available plaintext file. Next, you need to get an unencrypted file for each file type determined by the first 5 bytes and not anything else, not extension or anything else. It turns out I have more than 5,000 different file types, so I had to find 5,000 plain text, which is a difficult thing to do. So where do you get plain text files, unencrypted plain text files? It so happens that in modern life, rather than creating information, people download it from somewhere. If you look at your disk volume, 90, if not 99% of your disk space is not something that you created, but it's something that you got from external area. You get archives, photos, and you can search and find it in the internet. But you have to be careful, because if you download distributive in today and then in a week, the name and the way in the server can be the same, but there will be differences. There may be differences, or in case of video, the encoder settings could get different. The file will be different, although watching it, you would never, with your bare eyes, you would never notice any differences. So you need to control it, because otherwise you can get a wrong plain text and erroneously decipher your data. You may try and find unencrypted files, read-only, for example, was not encrypted, and the waste bin files were not encrypted, so you could find copies of files there. After deciphering one archive, you can decipher all archives of this type, like RAR or 7-zip and others, the most popular ones. And inside the archives, you may also find files which you do have encrypted versions. The reason for it is that you download the archives and you get the files from the archive, and then the archive is still on their computer. If people would back up copies to flash drives and other computers where malware can't reach them, then ransomware encrypting disks wouldn't have existed as an industry. But more often than not, backups are either not done or they're done but partially. Like your quarter report was also copied to another machine, and you have a copy of your quarter report, or you wanted to demonstrate some photos, so we also send emails, and we also use messengers, and we also transfer information this way, although messages usually overly compress your videos and photos, so it's not a very useful source of unencrypted copies of your documents. However, neither WhatsApp nor Telegram don't compress it. So if you send this file to someone, you may want to just ask the person to get you this unencrypted file back, and you can just decipher what you want to decipher. Obviously, there are a lot of issues here, because certain types of files, like video files, first 5 bytes of them may have all kinds of variants, and you'll have to check through all of them. Should you have a file available to be read by user, like natural language text, not a Word document, but ASCII text, or a program in a programming language, then it would be easy to see whether it's the right file or not the right file. If you have a lot of files of this kind, then you can build a so-called distinguisher. an algorithm to differentiate between the right file and the file that is not right. You have, in Russian language, you have words and you have spaces and you have syntaxes rules, and you can take it all into account in building the distinguisher, which symbol can follow the other one. Or in English language, Q is almost always followed by U, unless it's an abbreviation. Knowing that, you can pick everything fast so that all the files encrypted on this key will be deciphered in the right way. Basically, this is a part of cryptanalytic cryptographic attack. It's very expensive to realize it for each type of files. So for the type of files that have low redundancy, like archives or encrypted files, you will never be able to build a distinguisher like that. Mathematics won't help you out there. This method only works on a narrow spectrum of files. Well, I spent several evenings of several months to process all files for which I could find an open text. And de facto, I could decipher 88% and 9% of the file, and 4% of the volume of files I failed to decrypt, to restore. Only 10% data encrypted is a good result. It already made me happy, but there is a subtlety here. I only deciphered less than 40%, around 40% of file types. I mean, the more often a certain file type using first 5 bytes as your guiding star, well, the more like that, the easier it was to decipher it. The most valuable files, unfortunately, stayed encrypted, and he wanted me to do something about it. So I decided to go for it and started to work on it and started to try and do something about those 5% of data. At that point of time, thanks to a good person, I got a sample of this malware. A sample of this malware that would add extension masoc on top of the file. I understand in reverse engineering, so I decided to reverse engineer it and understand how this malware interacts with the external world. It turns out that it sends a request where the host and the root may change version to version, then PHP is called, and 2 arguments are sent. PID, the hash of the MAC address of the network adapter, where the malware works, and PID first, true or false, depending on whether it's first. And then JSON response with line 1 or line 2. And the way I interpreted the meaning of this field, line 2 looks like is the ID, because I could see the same line in the tail of the files, and line 1 was the key to use to decipher the data. So the ID was added to each encrypted file and included in the ransom demand like that. ND5 was calculated, then 6 digits in upper registry, 5 symbols, then next MD5 calculated, and then I would get the key that would go to Salsa 2.0 stream cipher. Not a very widely used one, but you can find source code for the Salsa 20 stream cipher. And then I looked at 153 bytes starting from offset 5. If I know bits and pieces, if I know key even after the first MD5, I still can't find the original key. I don't have the mathematics for it. There is no attack to let me find the key. So I really need to get the key sent by the server. Obviously, I thought of asking the server to give me this response because URL is encoded there. I can get it, but problem is that there was no information about the key in the malware. For it, it's just a string of any length, any set of characters. You would just get it and put it into MD5 and thus calculate the key for the file. So I requested the server, but I would get this. To the point when I found the right URL to ask the server to respond, the server was no longer responding. The good things I highlighted in red, that it's on Win64 and that it's on PHP 5.6.40. That will be helpful for us in the future. So what can we learn about the key if you don't know anything? Well, since the key and the ID that I did manage to extract from the malware body had the same length of 40 characters, and they contained funny, peculiar features. The ID would always have T1 in the end, and the key always ended in T2. Probably it was just an accident. Probably not. I mean, both 1 and 2 and then T and T. So I used Stop Decryptor from Blipping Computer. I downloaded it from Blipping Computer. And then I looked into the memory and I looked at the string that I extracted from the malware. And I got a lot of strings, 40 character long, and half of them had T1 as their ending and the other half T2 of their ending. And some of them, those strings, I could see in the forum when people would say that our identifier is this, and they had T1 and T2. Looks like there are several pairs of IDs and keys. This was my first conclusion. And most probably it's also of 40 number was from the same set of characters. That's why I encountered the situation that server returns me something, but I don't know. I mean, I can assume what it returns. It's a 40-character string, but I don't know how it's formed, and I want to try and guess it. So, say you are a C coder, and you want to generate a C code string 40 characters long. The easiest code is here on the screen. You take an alphanumeric alphabet, and randInd should be from 0 to 1 minus sense of alphabet, and that's all you need. So the alphabet can be anything, any string. In the ID that I did collect in the forum that I saw in Stop Decryptor, I saw the alphanumeric strings, alphabet most probably 26 plus 26 plus 10, and, well, int may be written differently. If you want to get a function from 0 to size of strings, this is what you usually use. randInd and alphabet can be also realized in a different way. Obvious variants for alphabet are given here. More often than not, letters are in alphabetical order, first large case, then small case, and then before or after all the letters you get the numerals. Another option is to have numerals going not from 0 to 9, but from 1 to 0. So you just press all the buttons all the way to the 0. I find this option counterintuitive, but some people say that this is another way to do it. Some variants of randInd generation, randInd string generation. You'll just see all symbols of the alphabets generated one by one in particular sequence. On the right, You can see highlighted in colors the order of generation of different symbols. Another popular way is when you get unknown dimensions of an inputting argument as something of a particular dimension. So you get this floating point kind of expression, and the number of symbols is different. In terms of equal probability distribution, you want to use the last option, but the last option is twice as long as the two previous options. There are some people who write it this way. The code is that I asked for help. Only one person offered me this variant, but he is a Haskell coder, and his opinion is therefore not really applicable to the environment where people write very streamlined and simple code. The people who write malware most probably don't have systemic minds and don't write in Haskell. So the last option is not very probable. You see here all characters repeating same number of times. So which algorithm could have been used? There are multiple algorithms of function. Maxrand, maximum amount of characters. I mean, the rand function gives us the value from 0 to rand max, say. So if you take your standard rand from a Microsoft Visual C library, then maxrand would be 15-bit. If we're going to take randoms from bytes from OpenSSL, if it's empty rounds, then the 31-bit. So if you try and use different algorithms to identify the probability of unevenness of various symbols, then for 15-bit randmax, the irregularity is 0.19%. On big volume of data, it's quite noticeable. If you have 8, then irregularity leaps to the eye. If it's 31 bits, then irregularity is so small that you would have to use several million, if not billion, of symbols to put your finger on this kind of irregularity. Thanks to that same kind person, I got URL to a script that is still alive to a different version of malware. It's worth mentioning is that since August 2019, when my acquaintance was infected, the authors of the malware changed the logic and they started to use asymmetric cryptography. And rather than returning a key, they would return an open RSA key that they would use to encode, to encrypt the key that they used in the malware. Though they had public key and ID, I wrote a script that would respond in parallel several streams, and a server stopped responding, but I did manage to get almost 10,000 unique IDs. And the public key is something that couldn't help me, but 40-character unique IDs were collected, and when I looked at statistics of various letters, I realized that it couldn't be 8-bit or 38-bit randmax, which means that neither of the algorithms that I expected to work would work in this particular case. Next thing, I Googled PHP random string, and I got the code that you can see on my screen right now. And there and then, the advice was to use not rand, but rather MT rand, or even better, random int. Let me digress a little bit into a random number generator in the PHP interpreters. There are a lot of them. Interrand is an MSM twister. It's a relatively simple random number generator with a very large period. And people love it because it doesn't ask for a lot of calculations to generate those numbers, and it gets this huge period. So rand function can be realized using a random library function that is only present in Linux. If random is not there, then lrand 48 can be used, also Linux only. If we work somewhere where we don't have random or lrand 48, you either use standard C library from the library of the programming language in which PHP was configured, or do rand, which always works if the end thread safety is enabled. And random int that they recommended me to use is only available in PHP 7 plus, and I have PHP 5, so not interesting. So I took out the algorithms that I couldn't use, so I could either use empty rand, first line, or standard C library, or do rand, depending on the mode enabled. So this is how it looks in do rand and in Microsoft Visual Studio, because we did see Win64 in server response, right? Remember? So max rand is 15-bit. So basically, it means it's not the algorithms that were used to generate the IDs that I managed to collect. Another small digression on how initiate states of PRNG is set in PHP. If you want to do it on your own, you have srand and mtsrand set rand for you. Works with 30-bit integer. It's optional. You don't have to mention it. If you don't mention it, then the code would use generate seed macros that would look at several sources of randomness, and they get reasonably good uncertainty, and they would generate 32-bit integer. If you use the lazy way of getting pseudo random numbers inside PHP, then you either use rand or empty rand, and then srand would be called for automatically. PHP interpreter would initialize the initial state. So we do know that there was this fact. What else we know? What else can we do to optimize the process of finding the right seed, the right initial value? We do not know the alphabet, but in some lines, we see same symbol repeating, like 9 is repeated 6 times in the string. If rather than checking that it's in position this, and that, but we rather see that there is the same symbol, then irrespective of alphabet, for this string, this condition should be fulfilled. That there is an identical character in this position. So I wrote, I love Python, but this case I wrote a C code that initiates empty rand with all possible seeds. I had it to power 32, and generate long string using the algorithms that I took from the algorithm. Only I used not rand but empty rand, same but realized in pure C. And then I check matches in alphabet-independent way for IDs with 6+ identical characters. I see whether or not this particular string complies with particular requirements. And at a particular point of time, I got the seed that got me full identity with the lines that I got from the real server as a server response before it was removed. I got several matched IDs at offsets that could be divided by a multiple of 40, 240 and 480. Looks like strings are generated in bits of 40 characters and never in a different way. You never had strings with offset of 3, 4, 5. So as I got the string, I could confirm that you first have the number, then large letters, then small letters, and I wrote a different utility that would use binary search that allowed me to find the IDs that would generate very, very long strings. And the moment the ID would give me at least one match, I would check it for very big lengths, more than 100,000 steps of 40 characters each. And using binary search, I would try and look for matches in the IDs that I had extracted. Some ID matched at depth of 600 steps. String derived from the same seed generates my friend's infection ID at step 1000 plus. So when I made one step back, knowing seed, I can back engineer it and get all the values. So I got the previous value, and it turned out to be the key. It allowed me to decipher all the files that were there on my friend's computer. In parallel, I picked 1900 various IDs that I got from Lippin Computer Server. And for all those ID, you theoretically also could have deciphered the data. At that point of time, I realized that I want to share this knowledge for good use. And I looked at the vendors who have solution for this type of ransomware. Turned out no Russian vendors have it for one particular reason, because the ransomware used servers situated in Russia, but it would check a local, and if it was launched on a machine with Russian local, it wouldn't do anything bad. So looks like they're living in Russia, and just to decrease their risks, they didn't infect the Russian Federation computers. So that's why Russian Federation vendors never encountered this ransomware. MC Soft was the most advanced one who did indeed launch a free-of-charge decryptor in October 2019. They realized there are 148 different, offline keys from 148 different versions and known plaintext attack. They also realized attack based on open text that I referred to in the first part of my presentation. It was done through online. I would launch their scanner, and he would see that this kind of ID and this first 5 bytes were there in the database, and then they would use it to decipher data on local disk. According to their estimates, at least 116,000 confirmed victims of malware, one of the strains of this malware, and more than 160,000 victims all in all. When talking to MC Soft, I realized 800 plus infected computers that could be recovered. They added it to their utility, and people could decipher their data without addressing anyone for help. It also turned out that offline keys and IDs, although T1 and T2 were not generated but rather manually included there, were also generated with the same algorithm. And you could have generated a similar line, exchange the last symbols into T1 or T2, and also change a couple of other characters, and thus get the ID string. So if you would find an ID, you would be able to look at the previous string, correct couple of symbols, and get the key, and thus decrypt the data. So if it was encrypted on offline key, but you didn't have the sample of the malware, was the way for you to go. But I couldn't check it in practice. But mathematically, this approach should have worked. Turns out that nearly 700 strings could not be generated even partially from any known seed. Sometimes the strings were with mistakes and I would correct them, even with a different alphabet, even from offset not a multiply of 40. So I thought, what can be changed in the algorithm to go to a different algorithm, the known one? What if they would use rand rather than empty rand? So I checked that, and turned out that 200 of those 700 strings could be generated using a more simple algorithm, rand rather than empty rand. Because the responses that I looked at were generated with empty rand, but it turned out that it could have been easier with rand-generated strings. All in all, I collected 35,000 strings. I failed to get parameters for 495 strings. Probably those are just errors, or the algorithm was different. But the success factor is pretty good, and hopefully the work I've done did help recover data, not just to the acquaintance of mine, but to many, many other people. Just because the authors of this malware made use of pretty logical ways of creating their strings, and I guessed their logic, and that's how I managed to do it. That's all I wanted to say. Hopefully you loved it, and thank you for your attention. Thank you, Dmitry. Judging by the number of questions in the chats, people started thinking of how to do it on their own and how to go through this way. We don't have any questions in the chat at this point of time. Hopefully your experience helps them. Should we have any questions, they'll write us in the chat or email. It's pretty easy to find you anyway. Thank you for this presentation. Thank you for going so deep. And you did help a lot of people who suffered from ransomware. Thank you very much.